Welcome back, everyone. Ready for another deep dive? Today we're looking at LLMs, large language models. They're becoming so important these days. And we got a request to look at a paper about a problem with them. It's tough to make them good at handling long contexts.
Like reading and understanding a whole book.
Yeah, exactly. Hard to do in one go.
It is. And that's what this paper's all about. It's called LongPO, Long Context Self-Evolution of Large Language Models Through Short-to-Long Preference Optimization.
Okay, LongPO. Sounds complex.
Yeah. Well, the idea is that current methods, they just aren't that great at making LLMs good at short and long contexts. They're usually only good at one or the other.
Like an athlete who's great at sprinting, but they couldn't run a marathon.
Yeah, a good analogy. And that's where LongPO comes in. It's a new approach, uses the LLM's strengths with short contexts to help it get better at those longer ones.
So like self-evolve.
Exactly, self-evolve.
So how does that even work?
Well, it's based on two main things. Short to long preference data is the first. So imagine you give the LLM a long document
Okay,
and then a short piece of that same document, along with the same instructions for both.
like showing the LLM the whole picture and then a zoomed in part of it.
That's it. Now, the LLM has to generate responses based on both the long and short contexts. We assume that the short context response will be better, though, because that's what LLMs are good at already.
Using its existing skills as a benchmark. But how does it learn from this? How does comparing the two actually help it improve?
That's where the second part comes in, the short to long constraint. So while the LLM is learning to process the longer contexts, this constraint makes sure it doesn't forget its short context abilities.
So it's like when you're learning to jungle, you don't want to forget how to bounce a single ball. You need to be able to do both.
Exactly. This constraint, it uses something called Koback-Leibler divergence or KL divergence. It's a way to measure how different two probability distributions are.
Probability distributions. I'm not sure I follow. How does that relate to LLMs?
Okay, well, a probability distribution describes how likely different outcomes are. So for an LLM, each word it generates has a probability attached to it. The LLM's output then is like a sequence of probabilities.
Oh, okay. So this constraint is keeping the probability distributions of the long context responses similar to the short one.
Exactly. That way, and it gets better at the long stuff without messing up the short stuff. It's all about balance.
This is making more sense now. We're having the LLM compare its own work in different contexts and then using this constraint to make sure it doesn't stray too far from what it's already good at.
Yeah, it's pretty ingenious. To test it, they gradually increased the context length that the LLM was trained on. So they started with 128,000 tokens, then 256,000, then finally 512,000.
Wow, that's a lot of text. But why did they gradually increase it?
Well, you wouldn't start training for a marathon by running 26 miles on the first day, right? You have to build up to it. It's the same idea here. By increasing the context length slowly, it lets the LLM gradually build up its processing power so it doesn't get overwhelmed.
Okay, so building up its endurance. I get it. So did it work? What kind of result did they get?
That's where things get really exciting. Well, they found that long pull did a lot better than the usual ways of training LLMs, like way better.
So it was actually better at teaching them how to work with longer pieces of text? Like what made it so much better?
Okay, so think about how those other methods work. Let's take supervised fine-tuning, or SFT for short.
Okay, SFT.
So with SFT, you're basically giving the LLM instructions and then the perfect answer. So it learns by trying to copy those perfect answers as closely as it can.
Oh, so it's like, here's the question, here's the answer, now memorize it.
Pretty much. But the thing is, SFT doesn't really care about the difference between short and long context. It just tries to match the answers no matter how much text there is.
Right. That makes sense. It's like trying to study the same way for a pop quiz and a final exam. Doesn't always work, right?
Exactly. Now, direct preference optimization, or DPO, is a bit smarter.
Okay. DPO.
Yeah, with DPO, you give the LLM two different answers and then ask it to choose the better one. So it starts to learn what a good answer looks like.
Oh, so it's learning to judge quality.
Yes. But even DPO, it doesn't really focus on the problems of long context. So the things it learns about quality might not work when things get really complicated with a ton of information.
And that's where LongPO steps in, right? With that short to long constraint, it keeps everything balanced.
Exactly. By adding that constraint, LongPo constantly compares the long context answers to those good short context answers it's already good at, like a quality check.
So cool. Learning to handle tons of information, but not losing those core skills. You mentioned that it was also better at keeping Mistral 7B's short context performance good. Why is that so important?
Because we don't want LLMs that are only good at one thing. The goal is to have them be really flexible, like able to handle all sorts of tasks and different lengths of text.
Yeah, it's like training an athlete to be strong and agile. You wouldn't want one at the expense of the other.
Exactly. So LongPo was able to do that for Mistral 7B. It did great on the long stuff, and it either kept or even made its performance better on the short stuff too, which is something those other methods struggled with.
Wow, that's awesome. Anything else about the results stand out to you?
Yeah, a couple things. So with Longco, Mr. 7B, remember, it's a smaller model, was actually able to perform as well as, or even better than, these giant models, like the ones that were trained with the tons more data and resources.
Wow, that's kind of like finding a shortcut to becoming an expert.
It is, and it really shows how efficient this whole self-evolving thing is. They also tested Longpo on a bunch of different tasks to see how well it really worked.
Oh, like what? What kinds of tasks?
Well, one was a question answering task, but it was based on whole books. Imagine asking a question about a 500-page novel and getting the right answer.
Yeah, that would be so useful. So how did LongPo do?
Mistra 7B, trained with LongPo, blew the other models out of the water, even the huge ones. It really shows how LongPo helps LLMs understand complex, long stuff in a whole new way.
That's amazing. Any other tests they did?
They also tested LongPo on a benchmark called Ruler, which is specifically for testing how well an LLM understands long contexts. And again, LongPo did great. It showed how well it works across different long context situations.
It's like LongPo is helping these these super readers. They don't just process information, they understand it, like all the subtle connections and stuff.
That's a great way to put it. Really remarkable.
I mean, this is super cool, but I imagine there's still some kinks to work out.
Of course. No method's perfect. LongPo probably has limitations. One thing is that you need a good short context LLM to start with, so how well it works might depend on how good that initial model is.
Makes sense. Like building a house on a strong foundation. Got to start with a good base.
And another thing for future research is, well, can this LongPo idea work for other types of self-evolution? Like, could it help LLMs learn new languages or specific skills? Those are all questions researchers are looking at now.
Wow, it's like we're giving LLMs the tools to become lifelong learners, just like us.
Yeah, the possibilities are huge. It's a really exciting time to be working in this field. It's always changing, and we're just starting to understand what LLMs can really do.
Okay, we've covered a ton today. Before we move on, I just want to get your overall take on this LongPO method. What does it mean for the future of LLMs?
For me, it's a big step forward. It's a really promising solution to that old problem of balancing how well LLMs understand short and long contexts. And the coolest part is it doesn't need huge amounts of labeled data. That's always been a big hurdle in LLM development.
So it could actually make these powerful technologies more accessible and speed up progress in the field.
Exactly. And it opens up a whole new way of thinking about self-evolving AI system.
I'm already picturing a future where we can have deep conversations with AI that has read like entire libraries of information.
Let's not get too carried away, but it's definitely a cool possibility.
Okay, before we wrap up, I wanted to go back to something we talked about earlier, the ablation studies. You said they were really important for understanding how LongPO works. Can you break that down a bit more?
Sure. So the ablation studies, they were like taking LongPO apart to see how each piece works. By removing one part at a time and seeing how the performance changed, they could figure out exactly what was making it work so well.
Oh, like taking apart a clock to see how each gear makes it tick.
Perfect analogy. They found that both the short to long preference data and the short to long constraint were super important. Take away either one, and performance tanked.
So it's not just one secret ingredient, it's the two together.
Exactly. And when they removed the constraint, the LLM's short context performance went way down. So that balancing part is super important to make sure it doesn't forget the basics while learning new things.
It's like this constant push and pull, pushing the limits of what the LOM can handle, but also making sure it remembers what it already knows.
Yeah, and long posts. Oh, hey, welcome. What's up?
So there are two steps to do the deep RPO. So the LongPo's object function. Can we explain this one?
Oh, you're asking about the LongPO objective function.
Yeah, so the LongPO objective function is a math equation.
It tells the LLM how to improve when reading long documents.
It's related to DPO. It tweaks DPO to work well for long context.
It has two parts, just like we talked about.
Yeah, it's all about preference and constraints.
The first part encourages it to prefer answers.
It prefers answers that are similar to the short context answers.
The second part is the constraint.
It's a check. This keeps it from straying too far from the original.
The math basically makes sure the LLM is learning from both.
It's not forgetting how to do short context tasks.
Did that help clear it up a little bit?
Before we move on, I wanted to make a quick pause.
And then we'll come back to wrap up this deep dive.
Okay, we're back. And this stuff is incredible, right?
It's crazy to think about what this could mean for AI.
What's cool is that it's not just about scores.
It's about changing how we think about AI.
We've always focused on bigger models.
Maybe we should be making models better at learning.
Exactly. This idea, self-evolution, could be huge.
Not just for language. Think about self-evolving robots.
Or AI making music.
Robots adapting, AI writing symphonies.
True, but we're just getting started, remember?
LongPO is just one way to give AI the power to learn.
It does feel like a change is happening in AI.
But with any tech, think about the ethics, right?
Oh, absolutely. As AI learns, we need to make sure.
Always got to balance progress with responsibility, right?
For sure. But self-evolving AI has such potential.
Imagine AI helping us solve climate change.
Or helping create new tech.
It's exciting, but a little scary too, I guess.
Yeah, definitely. So what's the most interesting thing?
How clever LongPO is.
It really is. It shows creativity in this field.
This has been an amazing look into LLMs.
It's been fun, and I hope everyone found it interesting.
Thanks for joining us on the deep dive.
We'll be back soon.
Keep exploring and learning.
See you next time.